Well folks, this is Dan Abbott. I teach at Southern Maine Community College. I'm making this video to show students in my SolidWorks parametric modeling class how to design using the top-down system as opposed to the bottom-up system. This is what we're going to be making. I just pulled this drawing off of a YouTube video, and I will point out that it uses both first angle and third angle projection in the same drawing, which you would never do, and it also does things like put the units in, which you wouldn't do. So I don't want anyone to think this is a good technical drawing. It also uses the ISO standard for dimensioning, where the dimensions are above the line and they are aligned with the dimension line, which is not the way we do that in the United States. They'd be horizontal and broken. But it does show you what the part's going to look like pretty clearly, and it shows you all the individual parts as well. What I'm going to do is start with the bottom plate, the plate that holds everything together. This is similar to the caster that we've done in the class. It's just upside down for the caster, as the parts are looking a little different. Let's go to SolidWorks. There are two ways you can start this. You could make the base as an individual part file and then bring that into an assembly, or you could build the base in the assembly itself. I'm going to do it that way, just so everything starts with the assembly. So I'll go to File, New, and I'm going to start a new assembly file. I actually have templates set up myself, but you probably won't, so let's start with Novice. Oh, I updated SolidWorks and I haven't yet cleaned up the templates, but that's why we'll just start with a blank template. Now, the first thing it does when you start an assembly by itself is it asks you, hey, what do you want to use for a part? So it goes right into the Open dialog box for files. I'm not going to open anything, so I'm just going to close that. Again, I could have made a part and I could have started by opening that part in the assembly, but so I'm going to go here, and when it asks me what I want to do, I'm just going to pick the green check, which just leaves everything blank. Coming down over here, I want to make sure this is in millimeters, although each of the parts, this is a sort of weird little thing in SolidWorks. Every time I make a part in this assembly, I've got to check those units, and it's quite likely that those units are set to inches for each part. So I will go to Insert Components, and I'm going to start not with Insert, but with New Part. It all automatically comes in with a little green check, and what it's asking is, put this on the plane you plan to draw on. Now, usually you get an instruction over here. In this case, it's at the bottom. Select the face or plane in which to position the new part. For this base, I'm going to draw it on the front plane of the assembly. Now, once I do this, it's the last time I'm going to use the planes in the assembly. After this, I'm going to do everything based on that bottom plate. But for this, I'm going to pick the front plane of the assembly to draw on. Looks like that. Now, I'm going to start. Try that one more time. The front plane of the assembly looks like that. And I'm going to start with a center line, really a construction line. I'm going to start with the center line, go directly above the origin, bring it down through. And what I'm going to do is draw half of this on one side, and then I'm going to mirror it to the other half. I will draw, I'm going to actually start this right on the origin. So the origin is going to be on the top of the part itself. I'm going to come over, down a little bit, over a little bit, down a little bit, come back, go up, come back over. You have to be very careful with this because you're going to put dimensions on it anyway, as long as it's close. Even if it's not that close, it'll still work. Make sure copy is checked off when you do the mirror on something like this. It comes across like that because it's a symmetrical part. And you'll notice, indeed, it changed from millimeters to inches when we went into the part files. I'm going to change that back to millimeters before I place any dimensions. Now, the parts listed over here, at the moment it's blue because we're working on it, and everything else is grayed. Well, not grayed out, but it's the only thing we're currently working on. I'm going to go over here, and I'm going to right-click on the sketch and edit it. Now I'll start putting my dimensions in now that it's set for millimeters. I will have to do that for every part we create here. What I probably should have done is change the default setting from inches to millimeters, but that's okay. So the overall length of this is 120 millimeters. You put that in like that. That depth from here to here is 3 millimeters. The depth from here to here is also 3 millimeters. And then that distance from here to here is 10 millimeters, and that width right here, I've got to look at it and see. It looks like it's 50. And Oh, this looks a little different than I thought. It's actually not vertical. It's got a little angle to it like that. You'll notice it changes on the other side as well. So the distance from here to here on this is given as 56. And now I'm going to have to drag this over a little bit. Oh, wait a minute, something weird happened. I typed in a 5, I guess, and not a 50. Didn't even notice when I did that. There we go. Now what I'm going to do on this is bring that point over a little bit so the angle goes the right way. That angle was given as 45 degrees. So I'll just pick 2 lines here, bring it down, make it 45. And that should be fully defined, and it is. Now the thickness of this is 72 millimeters. I'm going to do a mid-plane extrusion. So I go to Features, Extrude, not blind, instead mid-plane. 70, I just said it, but I forgot, 72. So now it looks like that, and that puts everything right in the middle. All the planes on this part go right down through the center. Now I'm not going to put the fillets in yet, and I'm not, because there's always a tendency in a case like this to put in the fillets and then use the center of the fillets. I'll just show you what I'm talking about here. You've got holes here, and those holes happen to be in the same location as the center of the fillets themselves. But if I change the corner fillets after making the hole concentric with the fillet, that would change the location of the hole. So what I'm going to do is make the holes 96 millimeters apart and 48 millimeters apart by putting the first one in place. And there's a couple ways I could do this. I could measure that from the center of this so that everything stays symmetrical. And that's not a bad idea, but I also could just go from one edge in. So it really depends on what my design intent is. My design intent is to have that always be 12 millimeters in and 12 millimeters in from the sides. Those are the dimensions I'd use. If my intent is simply to make it make it symmetrical about both planes, then I might put it in the other way. Let's just say no matter what I do to this, I always want those holes to be in 12 millimeters. So that's what I'm planning to do, and that's what I'm going to do here. So now I'll go back to Features, and on Hole Wizard, we use a Hole Wizard on this. We could just use circles. First thing I'll do is put in the type. Now let's go to position first. I'm going to put the position of one hole in on that surface right there. Now I'm going to dimension that. When I dimension it, it's going to say 12 millimeters from each side. Again, that's the same as the fillet, but I'm going to put that in independently so that the fillet doesn't control the hole. I could make the hole control the fillet. I went the wrong way. I could make the hole control the fillet, I suppose. But I'm just going to leave them independent on this one. All right, so there's my hole. Now I'm going to say I'm done with the dimensioning. I'm going to go back to the Hole Wizard and change the type. It's going to be a drilled hole. The hole size is 10.2. So I'm going to go down under ANSI metric drill sizes and see if there is a 10.2. There might not be. It might not be a standard size, but there is right there. Now I'm going to go up to surface, which I think is always the safest way to do this. Pick the surface to start from and the surface to go to, and you're less likely to run into a problem when complex parts. The hole's in there like that. Now what I want to do is to mirror this around the planes, not the planes in the assembly. I don't even think it'll let me do that. We'll find out. But the planes in the part itself. So when I go to do the mirror, I'll go up here to the Features tool, go over here to Mirror, and let's just see what it does. And is it even going to let me pick that as a mirror plane? No. In other words, I've got to go to the part itself. That makes sense. I don't want to be mirroring around the assembly. I really want to be mirroring around here. So let's just say we'll go to the right plane, mirrors over there, say OK. Now I'm immediately going to go back to mirror, and this time I'm going to go down on the base and I'm going to pick the front plane. Front plane mirrors the last thing that I did, which is the other mirror, so now they're there. Now those holes are always going to be 12 millimeters in from the sides. Now I can put in the fillets, and this would be a perfectly good time to do it. And I put in fillets at the end, almost always. And again, in this case, I wanted them to be independent because I don't want the fillets driving the holes. Fillets at 12, looks like that. Now that's everything I can do here for this part. and that's in, the part itself is completely done. What I'm going to do now is I'm going to create the next part by using that surface to draw on, which means I'm now going to come out of this, and now it turns into a standard part over here. The only thing is it does show you the way that it's identified here. It shows you that that's inside the assembly. You can rename that if you want. Wouldn't be a bad idea to rename it bottom plate, for instance. So I can do that, but it's still inside the assembly. Now when I go up to the insert components, I'm going to insert a new part by making a new part in the assembly. And now again, I'm going to get that little check. Don't pick anything in the assembly itself. In this case, everything from now on is going to be based on that part. That makes sense? Yes. Well, let me just take a look at this. Let's think about how we're going to do that. I could build the base on this, and then once I've built the base, I could build up this part right here. Sure, let's do it that way. So I'm going to put my sketch on the bottom of this. I'll build the base first, and then I'll add this other part to the base. That base goes all the way into up against the edge, so it sits right up against that edge right there. So I can either use that surface or this surface from the vertical line, or in fact I could use that front surface. Let's do it in the top. So, and again, this is the kind of decision you make based on what you think will be easier down the road as you start making changes. So I'm going to pick this as my surface. Now I'm going to convert entities. And I'll do a convert entities, and I'm going to pick this surface right here. And I can pick that surface like that. And now I'm going to convert all the entities of that surface onto the surface that I'm sketching on. I'm also going to convert entities again, and I'm going to pick the holes. Now that makes the holes of the part that I'm making dependent upon the hole size in the part that I just selected, the base. It also makes the overall outline of this the same. It's going to be controlled by whatever changes are made to the bottom plate. Pick OK, and that looks good. I just need to know how thick to make that. Let me look at my notes. 10 millimeters will do it, so then I'll go over to features. Extruded boss, I'll make it 10. This one's going to be blind, so it goes up. Oh, and once again, I forgot. Every time you make a new part, it goes to whatever the defaults of the standard default value. So when I typed in a 10, it made it 10 inches. I'm going to type a 10 again with an mm, and now it's 10 millimeters. Now, it's probably a good idea for me to change this to millimeters for the rest of these, so I'm going to do that. So now as I'm building this, I get the right units in there without having to type in the mm. There's a little notch out of this. Yeah, a little notch out of this right here. So I'm going to put that in there right now. I'm going to sketch on that surface right there. I'm going to put a little rectangle, a little corner rectangle. I'm going to start it here, drag it off like that. And then if I look at the drawing that I have, that notch is 4 high and 5 wide. So it's 5 this way, and it's 4 this way. First time I've made this particular part, by the way, but that's okay. I'm going to do this in the same way that you would build something for the first time. 5 and 4. Okay. Now I'm going to do is an extruded cut. On an extruded cut, once again, I think your best bet is always to go up to surface. Now there are times on really simple parts where you can go through all or up to next. But up to surface guarantees that your intent is always maintained. You know where it's going to start and you know where it's going to stop, no matter what. Right now what I want to do is to build in the piece. I want to build in the piece that sticks up. And I'm going to do the piece that sticks up by putting it on this surface right here. I'm going to build it on that surface right there. So I'm going to go to Sketch, pick the sketch. I'm going to do that one. Look at this from the right so I can see what I'm doing. I'm going to put a center line on here. And that center line is going to go from here. Let's go right down to there. And now I'm going to draw a circle at the end of the center line, and then make that circle, I am in millimeters, make that circle the diameter of the top of this, which is going to be 30. Now I'm going to start sketching. I want to make sure I sketch on where I really mean to be. Yeah, I want to start sketching on that line right there. So we're going to go to the line command. I'm going to start on this line. I'm going to start right there. Come over and have it stop here. And I want it to come up till it touches here. Is that what I want? Let me see something. No. No, it's not what I want. And what I want to do is to sketch up here. So I just started in the wrong place. I'm just going to start over again. I'm going to get rid of that. I want this to be on this surface up here. So I'm going to go to the midpoint of that line to start with. So I'll do that. I'll start right at this midpoint if I can get it to come up. And there it is. Then I'm going to come over here to that surface. Now this comes up above it comes up higher than the top of that, and it's 10 millimeters, so we'll put that in a minute. And also in a minute we'll change that so it's vertical. So then it's going to come over here, and it's going to come over until it lines up with the quadrant of this top. I can go and acquire that quadrant and bring it down. You can see it's got a tracking line. I can also add that as a feature later on. Now I just need to make this vertical, just because that's a little sloppy. I need to make this vertical. No, why not? Because of the orientation and the way. All right. Well, it's going to have to be horizontal. It just thinks it's drawing in a different orientation than I did. That is a surprise a little bit. I'm not sure why it did that. All right. Well, it did, so that's the way it is. Now I'll go ahead and draw a line. I'm going to draw the line from the quadrant of the circle and go straight down to here and make sure that that's also, and it's not, so I'm going to make that. There we go. I just need to reverse my thinking. I've got this is turned 90 degrees according to it, apparently. That's what's going on with that. Now what I'm going to do is to mirror everything. I'll mirror this line, and so I'll mirror all of these lines. And I'm going to mirror them about the center line. Bring it over here like that. Now I'll add these dimensions in. Now you notice I haven't really put many dimensions on here yet, because I'm letting the base drive a lot of these dimensions. And the other thing I need is a distance from here, and that is given on the part from the top of this. So that goes from here. And that dimension is 50. Looks like that. Now I'm going to trim out. Where's my trim? Right there. I'm going to trim out this and this. That should be fully defined, and it is. And I might as well go ahead and put the hole in this, because it does go all the way through, and it is concentric with that. So now I'll make that hole size the size given, and the size given is 12. So there's a 12 millimeter hole there. That's 12 as well. All right, we have a fully defined sketch now. Come back over here. And what I'm going to do is to extrude that (10 millimeters). So when I do that, I want to make sure it goes in the right direction. 10. It's going the wrong direction now, so I'll flip it. Now here's, yeah, it doesn't hit those holes, so it's not going to cause me a problem now. It's just going to merge, as long as you've got merge selected over here. So now that's what the part looks like, believe it or not, with that little step in it. Not sure what that step is for, but it has the little step. And we can move from there. Now there's a fillet in here that is part of the overall shape itself. That fillet has a radius of 15. I'm going to build that in now, just in case it causes anything to be different about the rib I'm about to put in. I'm going to take both of those, make them 15. Looks like that, and this is mostly what we have here now. Now there is a support rib on this. That support rib goes down here at an angle, and in order to draw that, I'm going to do this. I'm going to look at it from the front, just like this. I'm going to draw on the plane of this that goes right down through the middle. So I'm going to do my sketch. When it asks me what to select, I'm going to open this up on the inside, find the part that I'm currently working on, and I'm going to pick the front plane. I'm going to pick the top plane of that part. That's just the way it was oriented. Now if I look straight at it, I can draw a line that goes from that corner right there and goes up, and it stops below, stops up here someplace. Just make sure you don't hit the midpoint, because you're going to want to dimension this properly. And the dimension for that's going to be from here to the top. Should be 40. Now that's fully defined. Now I'm done with that. That's my whole sketch. I could actually draw a triangle and then extrude it. I just want to show you how to put a rib in. To tell you the truth, right now I probably would have just drawn in a triangle and then extruded it mid-plane, but I do want to demonstrate the rib function. So in this case, I get out of the sketch altogether, go back over to features, and then I find the rib tool, and the rib tool is right there. And so it asks me to select a plane, a planar face, or an edge in which to sketch this thing. And instead, I'm going to pick an existing sketch. That's the option down here, and that existing sketch is going to be that. Now what I want to do is to make it go in that direction. Material side should be down here like that. And then the width of that rib was given as up here. The width of the thickness of the rib was given as 10. I do that, pick the green check, and then it lays the rib in like that. That's a very helpful tool, so that's why I wanted you to see it. There are no fillets on this, which is a little bit of a surprise. I think this would actually be a machined part, but the one that was given doesn't have fillets, and that's okay. We're just going to make this to demonstrate something anyway. But generally speaking, I would guess that's a cast part, so you'd have fillets all throughout here. Come back out. Now I've got that part, looks like that, and it's right in place. Now what I'm going to do is use the mirror function in the assembly. And the mirror function in the assembly is under linear component. I don't think it's anywhere else up there. No, right there. So mirror function, and we're going to pick, once again, the mirror plane that goes down through the base, not the plane that goes down through the assembly itself. So I'm in the base, I'm going to the right plane, and then I'm going to pick the feature, or the component, I mean, that gets mirrored. And that component that gets mirrored is this one. Pick the green check, it comes over like that. Now so much of this was based on the base itself that if I go and make changes to the base, those changes are going to be migrated through. I'm just going to pause a moment here to show you that. So I'm going to say, let's edit this part right here. I'm going to edit the part in place. Everything else goes like that. But watch what happens now when I come up here and make a few changes. I'll make this whole thing a little bit longer. I'll go in here and I'll say, let's make this 140 instead of 120. The whole part gets longer. And you may have noticed that the parts that I made here stay in place right now, but we'll keep going and you'll see in a minute what's going to happen with that. So now I come back out of here and I'm done with that edit on this one. So I'll say I'm done with that edit here, and I'm still editing the part, but now you'll notice what happened is that the base of my side pieces, the axle supports, also got longer as well. Now what I want to do is go in here and I'm going to edit the hole size. And I'm just going to change the hole size so that it's now, instead of 10.2, let's just make it 12. That means all these holes are going to get bigger. When I come back out of that, now everything has gotten bigger. The hole sizes have gotten bigger. The sizes in the axle supports have gotten bigger. The axle supports have moved. That's the purpose of doing top-down design and assembly. I'm going to pause my video and just go back to the actual dimensions because I want to show you a few other things, but I do want to work this out with the dimensions that are there. Okay, now what I want to do is build the other components. I'm going to start, well, I could start with the axle. Let me look at something here. The way this is assembled we've got a bushing that goes into the wheel and is going to be pressed into the wheel and then be free to move back and forth. So it's going to be controlled by the wheel. The wheel is going to be controlled. Actually, it should be free to move back and forth a little bit, and the axle is going to be controlled by the bushing and by, looks like the length of the 80 millimeters. I can't tell if that sticks out a little bit or not, but we'll find out. So let's do this. I'm going to build the wheel right now, and I'm going to make sure the wheel is on the axis that goes down through the center of those holes. That's the main thing I'm concerned about. And I probably will leave it so that the sketch is free to move back and forth, because there's probably a little bit of play in this wheel. I haven't really thought about this yet, or haven't done it yet, but let's try and see what happens. So I'm going to start looking at it from the front. And again, I'm going to draw on a plane based on the base. So I'm going to draw on the front plane of the base. So I'll go over here to sketch. Yeah, because I want it centered. So I'll go over here to sketch. Open this up. Find the base. Bottom plate. Yeah, well, okay, that's the assembly itself. So we need to go down to the bottom plate. And on the bottom plate, we're going to pick the front plane. All right, now I'm going to draw I want it in the context of the assembly. I'm doing that on purpose. So what I'm going to do is draw a center line. I'm going to have the center line go right down through the center hole of this. Now the center hole of this is something I can't pick directly, but there are a couple of things that I can do here. One of them is I can turn on the center axes. And those center axes are the center axes of all the individual parts. And it's not showing for some reason. Oh, there they go. I had to turn on viewing. So you can see that I've got, when I turn those on, I have a little axis right here. So what I'm going to do is use that axis as a way of rotating. Yeah, I'm going to use that axis as a way of rotating the wheel around the axis itself. So I suppose I could, I'm going to draw a new one in that's connected to both of them. So I'm going to come up here, go to the center line. What I want to do is to snap to the axis. I'm going to look at it from the front. I'm going to pick the axis right here, and I'm just going to bring that all the way through here. And that's just going to locate it up and down. I'm not going to be concerned about side to side, but you notice that's black now. I can't go up and I can't go down. So it's associated directly with that axis right there of that hole. So if the axis of that hole moves, it's going to move this as well. And that's what I'm after here. Now I'll start drawing the cross section of the wheel. And to do that, I'll draw a line that comes right down through, center line that comes down through. This is one where I'm going to bring the center line down through here. But I just because I want to make sure that the wheel is free to move back and forth, I am going to delete that so the center line's free to move, and I'm going to use it though as a way of modifying or as of mirroring the wheel. So now the wheel is going to start here. So there's a hole in the wheel, so we'll get up high enough for the hole. I'm going to come over, come up at an angle till about here. Come straight up from there. Looks like we have another angle coming up. Doesn't go quite as far. Comes up like this and then comes back like so. So that's the rough shape. Now I don't need to bring this center line up, but I'm going to do it anyway. And the center line, the main thing is that it's vertical. That's my big concern here. Now I'm going to mirror these. I may decide that I don't like what I just did, but we'll find out. So I'm going to mirror this over to here, like that. And this is going to be one of those cases where this is not going to be fully defined when I'm done. I think that's what I want to do, because I want to make sure that it's still free to move back and forth so it has whatever play in it needs to have, but that it is in fact defined with relationship to this. So I'm going to put a dimension on here from here to here, but I'm not going to nail that down side to side. We'll see how that works. Okay, now I've got a dimension goes from here to here, and that dimension is, this is in millimeters, that dimension is 26. There we go. And for some reason it's set for millimeters, but it's giving me information in inches. I don't know what's going on with that. There are some glitches in the current release of SolidWorks having to do with dimensioning, and that is another weird little glitch. But you can see how it's not giving me the dimensions as millimeters, it's giving them to me as inches. Not even giving them to me as inches. What is it giving it to me as? Okay, now I want to make another component, so I'll come back over here to assembly. Under assembly, I'll say let's insert new part. Comes in as a new part. I'm going to draw it on the front plane of the base. That's where I want it to be located, because I want it to be centered on that. So I'll open up the bottom plate, which is this one right here, and I'll take the front plane of that like so. Everything else disappears on me. Once again, it changes to inches. I need to change that back to millimeters. Okay, now what I want to do is I want to see the axis that goes down through the middle of this. So I'm going to come up here and turn those things on. So right now they are turned on. Okay, so that axis right there is something I'm going to use, because what I want to do is to draw a center line that is coincident with the axis on one of those, or actually both of them. And I'm going to build the wheel around there. So that's what I'm after right now. And so you can see I can get a hold of that right there. I'm going to start by drawing a center line. I want that center line to be, can I get that or not? Let me see. I guess the reason I would like that center line, that center axis, rather than that edge right there, that's a tangent edge. That's the extrusion of the tangent edge. I could do that, but, well, the only reason that would not be, it would be an issue is if I ever wanted that round right there to have a different center than the hole, and that is not likely to happen. So I can actually use that tangent edge in this case. I'd like to be able to select that axis. Let me just see something here. If I go down, filter axes. Okay, if I go down and say all I want to do is select axes, and that's the only filter that's on. Oh, first though, since I'm sketching this, I have to sketch on a plane. So it's asked me to pick a plane, and the plane I'm going to pick is going to be, now I'm making the part on this plane already, but for my sketch I also need to be on a plane. So I'm going to go back and pick the front plane of this again. Now I should be able to draw a line, and I've got my axis set as my only filter. So I should be able to pick, yep. So that is picking the axis. That's exactly what I want. I want that axis to control the location. So I used one of the selection filters, but I wasn't selecting that tangency. That little filter that shows up tells me I've got a filter on. I'm just going to go turn all the filters off now so that I can draw the way I want. So now what I'm going to do is put another center line that comes down through, but I'm not going to center this. I'm not going to actually put this on the origin. I'm just going to make a vertical line, because I want to make sure that the wheel is free to move back and forth. Now I'll draw the wheel in here and rotate it around that axis right there. That axis is controlled by this axis, which means that that hole moves. It's going to move the axis of the wheel, and as a result the axis also of the axle that goes through there and the bushing. So now we'll do the sketch of the wheel, and the wheel sketch is going to start on here because it's got a hole in it. We'll go over, just looking at the shape, goes up a little bit, comes up at an angle. From there it goes up quite a little bit, about like so. Then it goes up at another angle, a little bit shorter, comes up like this, and it's going to come back, and I'm going to line it right up with that center line. You don't need to pull the center line up through, but it just looks, well, I want to make sure they're connected, so let's do that. There we go. Now I'll go ahead and put my dimensions on here. Well, before I do that, let me do the mirroring. So I'm going to mirror the entities that I just created about that center line right there. Now the wheel dimensions are off fairly considerably, but bring that up here, and that's going to be 40 millimeters. And this one down here is going to be, oh, actually this is the one that's 40. That's 40 millimeters. The one at the top is actually only 26 millimeters. There we go. And then this part in the middle looks like 15 on my handout. I'll look at it on the screen if I have to. $15 does not look right. Let's try 10. 10 looks a little better. Let's go look and see what it actually says. 8. 15 was bad. 10 is not good. 8 is better. There we go. Now, the other dimensions on here are, the whole size is 24, so the distance from here to here, and then down below, I'm going to make that 24. And the distance from here to here, bring that down below as well. That's going to be 30. And from that point, that's going to be 40. And then 66 to here. Looks like that. And then the overall dimension of the wheel itself is 76. So the wheel, bring that out here, 76. And then this distance right here has been given as a dimension of 70. Alright, now you will notice that some of these things are black and many of these things are not black, and they're black only where it's defined. If you notice, I can still move this back and forth, so the wheel is free to move back and forth. And I think that's going to be important to us. We're going to have to make a mate in between things later on, and that mate's going to be a limit distance mate, or I'll center it with a mate between the plane of the wheel. But I'm going to try this and see how that goes. So now what I want to do is a revolve. Go to Features, Revolve Base. I'm going to pick this. It gives me the wheel. Come back out of that part. And it looks like that. Let me go and get rid of my filters. Okay. Now I have the wheel, and the wheel is just, at the moment, is just sort of sitting down here. And it is not possible to move it. Why isn't it possible to move it? Well, like as I said, I hadn't built this before, and that was a little bit of a surprise to me. So what I'm going to do is let's just set it up for drawings, which means we want it dead center now. And so I'll go back into the part that I just created, and we'll edit that part. And what I'm going to do is inside that part I'm going to edit the sketch, and I'll edit that sketch so that it now lines right up with the origin. And once I've done that, it should be fully defined, which it is. It's also going to be dead center. So I think what I'm going to try later on is when we get done, I'm going to see if I can create a configuration where I change that. But we'll see. I'm going to have to look into that. Now, though, we've got it dead center, and so everything else is going to come off of that. Now let's make the bushing now. So we'll go back over to the Insert Components. We'll make a new part. This one's going to be the bushing. And once again, I'm going to draw on the front plane of the base plate. Base plate's right at the bottom plate. Right there, there's my front plane. Now we can start drawing. So what we're going to do is make a bushing, and I'm just going to make the bushing now so it's the same size as this is. So on this one, we're going to use this center line right there, and we'll rotate around that center line. Although it's another case where well, we're going to see. I think I can rotate around that center line. We'll see. I'm going to do a sketch, and I'm starting here, and so the bushing has a hole in it as well, and the hole in the bushing, say up here, going to go out until it touches that, and then I'm going to have it come up to, no, not quite. I'm going to go, oh, I see. I'm going to sketch from here, come back out past this a little bit. I'm going to go up past this a little bit as well. Let me see if that's the same size as the base. It is. So I'm going to actually match this up with that corner right there so it changes when that changes. I'm going to come over here, down to here, and then come in like that, come down to here. Now that's a little wider than it really needs to be. I'll move this up a little bit. So the bushing is going to look more or less like that. But you can see I snapped to the indications that I want to use as a way of controlling the size. Now I'm not going to be able to go in after the fact and put actual classes of fit sizes here. This is going to have to be driven by the wheel. But it's still a good way to go if what you're trying to do is to make sure that whatever changes you make in one part get reflected in the others as well. The dimension on this overall is 21. Oops, 21 millimeters. Got to type it in because I forgot to change my units to millimeters. Now I'll go back over to the sketch. On the new part that I'm making, right click, edit that sketch, and then I'll put the rest of the dimensions in. From here to here is 16. And then from here to here. Alright, so I am going to put a center line on here. And the reason I'm going to put a center line is so that I can dimension it with the diameter. I just think that's always a better idea to use the dimensions as given. Now the center line can be attached right to here. I'll bring it across like that. Now I'll put a dimension on. So that center line is the center axis of the wheel, which of course is what I want for this to be concentric. Now the size of the hole that goes through there, that's weird. It's got an offset of 3. That's very strange. I'll show you what it did. The dimension as given, which would never be actually given, was given as 3, the wall thickness. So we'll go ahead and do that. And now the diameter of the hole, here's the problem with that though. The diameter of that hole now is going to be controlled by the diameter of the wheel. That's probably not what I want. So I'm going to go back and just do a little bit of math and say, okay, let's make the dimension from here to here. We'll bring it down here. And we'll make that dimension the 24 minus 6, or 18. There we go. So it's the same dimension that we would have had otherwise, but now that hole isn't going to change size as we change everything else. Again, this is all in terms of trying to think down the road as what you might want to change as you're going through all these things. Come back out to features. We're going to do a revolve on this one as well. The revolve is right there. Bingo, I'm done. Come back out. Now we've got the bushing in there, and the bushing is where it needs to be. We would mirror the bushing. We'll do that right now. And again, I'm going to mirror it around the base. So we go to the mirror command under features, or under assembly, and that is under linear patterns. Open this up inside, find the bottom plate, find the right plane in the bottom plate, and then go in and just say mirror that, bring it over like so. Now we got that part. So the only thing left to do on this, except the fasteners, which I'm not going to bother to do, the only thing left to do on this now is the axle. It's getting into becoming a fairly long video. But I wanted to show you as just doing this from scratch without having done it before and make it as slick or as efficient as possible. Just because this is the process that you would go through if you were trying to design something like this in such a way that one part was going to control the others. Let's just throw the axle in there. When I do the axle, I'm going to start and do it in the same way. I'm going to draw it on the front plane. So it's a new part. When I want to know where to check this off, I go and find the front plane of the bottom plate. Looks like this. We'll look at it from the front again. And once again, I'm going to draw a construction line that goes right through the center axis of the wheel. Let's make sure it's a construction line, so it's for construction. And now we'll draw another one that is based on the origin right there. It comes right up through like that. So now I can draw my axle and I can mirror it one side to the other, and I can make changes only to one side if I want. So this is going to start here. Well, I don't want that to be the midpoint of that line at all. What I want is it to be on that line and also on the center axis of this. So I'll go to the sketch command and the line command. Yeah. What I'm going to do is bring this out like this, and then I'm going to put that line back down on there. I'm going to make a relationship between the two. It didn't have an automatic relationship. I'm just going to make a relationship. This is going to come all the way out to here. Now it's going to go up, come back, and then go up again. And it's going to come right down through here. And so the sides of the axle is going to be controlled by the sides of the hole in the bushing. We'll bring that right back over to here like that, and then leave it open. And now I'm going to make this and this collinear so that it sits right on the center. Now the dimension for that, well, here's another case where we probably want that's set to be 12, so we want that to actually be the same as this, so we can make those two collinear as well. Now looking at it from the front, the only thing we don't have then built in is this, and that looks like it's 15 from the end. And here's a case where probably what we're going to want when this whole thing goes together. And this is interesting that it doesn't fit together the way that the assembly on the one we're using showed. But let's just say we wanted to maintain a certain distance here all the time. What I would do here then probably is put a dimension in from here to here and say let's make a 2 millimeter distance here, maybe even a 1 millimeter distance, something along those lines. Now we have a fully defined sketch. I'm going to mirror it to the other side. And the mirror about line is going to be this one. Comes over here like that. Now we still have a fully defined sketch. We'll go over here to features and we'll do a revolve. And that revolve is going to be around here. Now we have the axle coming in, and we can go and try a few things out. So right now, if I were to look at this, what we have, let me just use a few more minutes. If I were to look at this and come over and do an interference check, there should be no interferences here because everything was matched up to the individual parts themselves. But the value of having done this is this. And probably yeah, I don't know if, well, but our goal is to have those things come here. And one of the things I probably should have done is built a chamfer in on this part right here. I can edit that right now. Let's do that. Put a chamfer on that edge right there. could even, it almost looks like that sticks out a little further. What I would probably have done then is not match it up here, but we'll put the chamfer in here now. So we'll go to Features, Fillet, get the chamfer tool, chamfer that edge, and chamfer this edge. And it doesn't specify the chamfer on that, so what I'll do is make the chamfer 1.5 millimeters. So let's just make it 1 millimeter. Now we'll come back out. Alright, so that's what we've got right now. Everything is put together. So what I want to test now to see what happens when I change the base. What happens to everything else? If I did this right, when I change the length of that base, it's going to change all the components, including the axle, and leave the wheel where it is, and the bushing where it is. But the axle should get longer. Those things should move. So we'll go back to the sketch under bottom plate. But first we're going to go and say, let's edit the bottom plate. So we'll edit the bottom plate. We'll open up the sketch for the first boss. Now let's just make this something kind of extreme. So instead of 120, let's make it 200. Let's see what happens. So we make that 200. Obviously it gets a lot longer. Come back over here. Come back out of this. And the whole thing gets longer like that. And what happens to the rest of it? It does this. Oh, okay, so the whole thing gets longer, but what I didn't change was that middle piece in here. So let's go and do that. That's what's going to really determine it. So, can I do that directly? It has to be saved. Let's save it and see. I'm just curious if I can directly. This is an assembly. We'll do that. It's going to save everything internally. So can I edit that sketch right there? Yep. So what I'm going to do is to make this now 70. Now I come back out. Come back out of here. Yeah, and so you see what happened now. Not only did the overall length control where that was, but it also moved this when I made this bigger, and it made the axle larger as well. Anyway, that's the point of having something that is top down. And the other changes I make, I'm quite sure, would do the same thing if I made a change to the wheel. So let's make the change to the wheel just for the heck of it. We'll change the revolve, edit that sketch. And right now the hole in the wheel is 0.24. Let's just make it, 24. Let's make it 20. Make it substantially smaller. Come back out, and let's come back out again. Now let's take a look at it cut in half and see if everything changed. And it did. Everything did change. In fact, that got awfully thin, so here's a case where I would also want to change the diameter going through here. Anyway, that's the idea of top-down assembly. And again, it's not something that people do all the time. In fact, most of the shops that I know don't do a top-down assembly unless they're doing a fairly complex layout, in which case they start with a layout instead of starting with an individual part. But that's the difference between top-down and bottom-up assembly.